Hey, boys and girls, today is Wednesday, February 3rd, and we are introducing a new workout for this month. A workout that you are probably very familiar with because every single month we look at the calendar grid, and every month we determine what the patterns are, what we think is going to happen next, and all those good things. And so that's exactly what we are going to do today. However, before I reveal the first marker of the month and the second marker and the third marker, since today is the third, let's talk about some vocabulary terms that are going to help us talk about what's happening with the pattern for February. Okay? So look at these pictures, and I'm just going to very quickly go through them. Here is a point. We have a ray. We have a line. We have a line segment. Then we have a ray that's connected to another ray with a point here. But now, because it's connected, it's called a vertex. And it has created an angle. Okay, so I kind of told you what it was called instead of me drawing it and asking you what you think it's called. But I wonder, can you define what these terms are? We know what they're called, but what is it? How might you define a point? Right, a point has a very unique location somewhere. And a lot of times you might see a point on a coordinate grid. Remember when we did coordinate grid stuff and we played that game where we had to figure out how much space was taken up by a certain color? Okay. How about a ray? A ray has one endpoint and then goes on forever in one direction. Well, how is a ray different from a line? Yeah, a line goes on forever in both directions. A ray only goes on forever in one direction. Look at this. This is a line segment. So where would we find a line segment? What is a line segment? A line segment is just a piece of a line. So I could take a line and put two dots right here and like cut that chunk out, and that's giving me a line segment. Or maybe even if I look at a ray, I can find a line segment within a ray. We also have an angle here. You can kind of see where my mouse is hovering back and forth. And I know you guys know what a right angle is, which is 90 degrees. But when we talk about angles, we have a couple different types of angles. And angles are formed when you have two lines that are connected, and that space, the arc between them, would form an angle. So we have acute angles, which are angles that are smaller than 90 degrees. And one way I remember that is I'm like, oh, it's so cute and little. It's smaller than 90 degrees. Then we have a right angle, which is exactly 90 degrees. And we've seen that because we've named right triangles before. Then you have obtuse angle. Say it with me, obtuse angle, which is bigger than 90 degrees. So an obtuse angle is bigger than 90 degrees. So which one is exactly 90 degrees? A right angle. Which one is less than 90 degrees? A cute little angle. And which one is greater than 90 degrees? Yeah, obtuse is big. It's a big one. And then we have something called a zero angle, where it makes no angle at all. And that's interesting because if we look at our very first calendar marker for today, we have a zero angle. Look at that. And how would we describe this line? Well, it's not a line, but it is a ray. It has an endpoint, and then it goes on forever in one direction. What does it kind of remind you of? Maybe like a clock? Does it look like 12 o'clock? Maybe. So we know that there is a ray here, and obviously there are two rays because it looks like one's shorter and then one's taller, and we could connect it to, say, maybe 12 o'clock. Let's look at the next marker. Can somebody use some of the vocabulary terms that we just talked about to describe this marker? Yeah, we also have two rays here. What time would that be if it were on a clock? Maybe 2 o'clock. Cool. Let's look at today's marker. Anybody notice anything that we hadn't talked about? A word maybe that we just went over together? Did you say it has a right angle? Yeah, this happens to have a right angle. It is a perfect 90-degree angle. We can put a perfect square right here in this angle, the space inside of that, those two lines that are connected, or those two rays that are connected. Okay, so let's look back at our vocabulary terms. Here, I kind of already told you what this is, but I want to make sure you were listening. What kind of angle is this? We have a couple choices. It's a zero angle. It measures 0 degrees. There's no arc or space or anything in between those two connected rays or line segments. Okay, how about what kind of angle do you think this is for our calendar marker from yesterday, February 2nd? What's it called? Yeah, it's so cute and little. Right, we know it's less than 90 degrees, but I'm wondering, how can we figure out exactly how many degrees this angle is? What if I were to tell you that you could use maybe a piece of paper, or I like to use my note card here because this makes a perfect 90-degree angle. How might I use this to help me figure out the exact angle on our marker for February 2nd? Right, does it look, it looks kind of like half of it. So I could take my marker and I could put it over the shape, and I could see that it looks like it's going halfway through the 90-degree angle. So then what would half of 90 degrees be? .45 degrees. So this angle is a 45-degree angle. And we already know what type of angle this is, but I'm going to ask you once again. It is a right angle. So let's look at the next day. I know that today is not February 4th, but just to kind of give us a really good handle on understanding angles and some more practice with using the terms that we went over together today, let's keep looking at some of the next calendar markers. Here's day 4, and maybe I can show you, well, this is pretty big. What can we say about this calendar marker? Yeah, it is bigger than 90 degrees. What do we call that type of angle? I'll go back and show you. We have a right angle, acute angle, obtuse angle, zero angle. What would we call an angle that is greater than 90 degrees? It's an obtuse angle. And I wonder how we could figure out exactly how big this angle is. So it's kind of hard for me to demonstrate on this computer screen here, but maybe I can add a line so that you can see what I'm doing. If I were to take a line, oops. So if I were to try to draw a line through this shape, I am using what I would call a benchmark, and my benchmark is 90 degrees. That's a really good benchmark because we like 90 degrees. We've talked about right angles, right triangles a while now, probably even in 3rd grade. So I know that this one is 90 degrees, but I need to figure out exactly what this is. Does it look like another calendar marker that we've already seen? Perhaps maybe on the 2nd? Yeah, and we kind of figured out, and I can draw my line here as well, that this was 90, and so now we have half of that, which is 45 degrees. So if I look at this shape, put my line here for my 90 degree angle, but now I have another 45 degrees. What's my total degree for this angle? 90 plus 45, which is 135 degrees, 135 degree angle. So we went from 0 to 45 to 90 to 135. So it seems like we're adding what each time? Yeah, maybe we're adding 45 degrees each time. Let's keep going and see what the next day would look like. So here was day 4. Just make a prediction before I show it to you. Yeah, almost looks like it, huh? What does that kind of look like? What would you call that? A straight line, right? It goes on forever, this way, and then we just have a point on the line. So, good thinking. I wonder what our degree would be. We know this is halfway. This is 90. And what does it look like down here if I were to put a line here? How many degrees down here would there be? It would also be 90. And 90 plus 90 is, you got it, 180 degrees. We're going to stop there for today, but I want to remind you of some of the vocabulary words that we went over in order to describe the things that we're looking at. We talked about angles, and we'll talk about the specific angles in a second. We talked about rays and points, but really we did more discussions around the size of the angle, whether it was a right angle at 90 degrees, an acute angle less than 90 degrees, or an obtuse angle bigger than 90 degrees. We also saw a zero angle where there was no angle at all. So every day this month, just like we normally do, we will update our calendar grid and we will record our observations. The one other thing that we need to do today is to update our calendar collector. So every day for the month of February, we are collecting what? We are collecting angles. So let's collect our angle for the day. All right, I'm going to go ahead and spin. I think it's very fitting that we are collecting angles and then our calendar grid also has angles. Looks like today we are collecting 15 degrees. So yesterday I was at 31. So you guys tell me, what's 31 plus 15? 31 plus 10 is 41, plus 5 is 46. So here's what I need to do. I'm going to change my color and maybe blue. And I am going to draw my arc to 46 degrees, right past my 45th line. And I'm going to use my straight line. Otherwise, if I were using it on paper, I would use a straight edge to make an angle from the center point to the to where it shows me what angle I'm at. So now, what angle are we at? How many degrees have we collected thus far? Yeah, 46 degrees. So I'm going to record that on my recording sheet very, very quickly. And that is all that we have for Number Corner today. You guys have a great rest of your day, and I will see you tomorrow. Bye-bye.